Dear Becca, how are you? I'm doing well. I hope you're doing well as well. It has been a while since I made a video, but my roommate is currently out looking for a new car, so I have some time to once again be an idiot and talk to myself. So please join me in this trip down memory lane. I don't know why I said memory lane, because I'm not going to tell you anything you ever knew before. It's all going to be new, so you shouldn't have any memories of it unless you can see into the future, which I don't think you can do. But you are a woman, which means you might have superpowers I'm unaware of. I wouldn't be surprised if women can all see the future, and they've been keeping it a secret from men. Please don't kill me if this is the case and I just uncovered a great secret. I promise I'll forget it within an hour. You know me, I'm kind of harebrained. I forget things. Anyway, I don't know what I'm going to talk about. This week was interesting. I thought about quitting my job. I thought about leaving it to go somewhere else because it was going to be really boring and I wasn't going to learn anything. Then I realized actually I could learn a lot. It's just I'm going to have to do my job slower than they want me to do, but I'll actually be doing my job better because of it, and I'll actually learn a lot from previous engineers who really knew what they were doing. So I am going to be learning. I'm going to be pushing a lot of paper in the process, but pushing paper and learning at the same time is better than just pushing paper and not learning anything. So I am going to be continually developing my skills as an engineer. Speaking of being an engineer, let's have a time of science where I explain to you what a rectifier is. So a rectifier is a circuit that takes AC electrical power and turns it into DC electrical power. Now technically I shouldn't say electrical power, I should say like an AC current waveform and turns it into a DC current waveform. That's a bit more specific, but you know, it takes AC electricity and turns it into DC electricity. We don't need to be specific. AC is the alternating current, that's where it goes like this, and DC is a straight line. Now what happens is that in the transmission grid, everything is AC. That is because we have transformers. I'm sure you've heard of transformers. They're the things that blow up and make sparks and take everybody's power down. But they also let us get really, really high voltages. And the higher your voltage is, the higher your efficiency is when you transmit power. If I were to transmit power at a very low voltage, it means I'd have to use a very high current and I'd lose a lot of that power over the resistance of the line. But if I have a really, really high voltage, then I can use a much smaller current to transmit the same amount of power. So we like AC because it's very easy to transmit. However, many applications, specifically anything that's digital, like your computers or your smartphones or anything like that, requires a DC waveform. And what happens is you need to take this and turn it into this. So what happens is you use these things called diodes, and they actually make it so that when it goes like this, instead of keep going down, it just goes whoop, whoop. It'd be easier if I drew a picture, but I don't feel like stopping this thing and then drawing a picture. Maybe as I get better at doing web videos that'll happen. But basically, you use a bunch of diodes, which are circuit elements that only let current flow in one direction instead of flowing in both directions, because AC goes from like +1 to -1 to +1 to -1. And with a diode, it would go +1 to 0, +1 to 0, that sort of thing. So you use a bunch of diodes, and eventually you just get +1. Now, actually, it's like a bumpy +1, but the specifics don't matter. But there's a rectifier. So I've been working with a rectifier because they want to relax the heat requirements of the rectifier, which might be fine, or it might cause the diodes to explode, and then there'd be a fault current, and then once again, you would destroy millions of dollars worth of taxpayers' money. So I'm going to do a good analysis to see whether we can relax the heat requirements of a diode. I hope you're doing well. I will talk to you later. Goodbye.